Hello, welcome to Seafood. My name is Chris, and today we're going to continue our series of looking at examples from the C programming language, the KnR text, and finding ways to develop some good habits from the outset, some good habits that are in line with more modern practices of writing C. So here is my tree. Today we're going to take a look at some copy I/O. So I am going to get there. And let's take a look right away at our example. This is the copy I/O example from page 17 in the text, as you can see up top there. And what this program does is it's going to take everything that we give it on input and just spit it back out to output. It's not that complicated, but it still does stuff. Now, before we compile this, we're going to apply the adjustments that we made last episode. We are going to specifically, or pardon me, we're going to explicitly declare that main is going to return an int, and then we're actually going to return that int. So this catches us up to some of the best practices we talked about last episode. So I'm going to quit this, and I'm going to compile. And because I got a couple of source files we're going to look at today, I'm going to specifically declare or name our output file today. We're going to call it IO. And this is our copy.io.c. We have no errors, which is a good thing, or no warnings at all. And we are going to run IO. And now we see that the cursor is blinking here. It's waiting at the next line. Our program is going to take input from the command line and spit it back out to output, which is also the command line. So if I say hello, it's going to print hello back to me. And I can give it 2 words. Well, this is definitely 3 words. And we got how you doing? It gives it right back to us. It's going to keep giving us the responses until we pass it an end of file. And in order to pass it end of file in the Unix environment, we're going to do Control D, which is a way to give your programs the end of file character. Okay, so let's go back and look at that copy IO example. In it, we're going to declare a variable of int, and this is C. We're going to be storing characters in this integer variable, and it might be a little bit confusing because we're storing characters. We do have a char type variable. We could call this char C, but we don't. And one of the reasons for that is it's an old Unix thing, and I mean the text does a pretty good job of explaining it. But one of the key reasons is we're not really sure it's implementation defined, whether a character is unsigned or signed. And in this example, we are comparing our return from getChar to end of file. We want to know if we've reached that end of file marker. And end of file in a lot of C libraries is represented as a negative number. I mean, it's a number that can't be a character, so it's a negative number. And if we see that, then let's get out of our input loop. So that's why we're using an integer. And again, the textbook talks about it pretty good. What we're looking at today is the actual definition of this integer. And this is an old style of doing C where we have to declare all of our variables at the front. If you've made it this far, you've already done the Fahrenheit and Celsius example in the textbook, and in that one there's a whole load of variables that are declared at the top of our scope. Our scope exists from the opening curly bracket to the closing one here. We declare all of our variables at the top of the scope, and then going through the program we use them where we need them. This is the older way of doing things. It's a way that they had to write C when it was first developed, just to let the environment kind of recognize all the variables it needs to allocate space for, and then you work with them. And the problem with this is that these variables are visible throughout your program, and that can be a problem, especially when we're using single letter variable names, which can be reused, and that you can get some shadows and some clashes and stuff. So let's restrict the scope of this C variable, and the way we're going to do that is we're going to use a for loop here, because we're allowed to now. So I'm just going to kind of mirror this above here. We're going to say for int C, and then we want to check that C is equal to get char, but not equal to end of file. There's our test condition, just like from our while loop. And then our last statement here in our for loop is usually going to be an increment or a way to increase C, but we're already doing that in our test. So we can leave this blank, and that's okay. And here we have a for loop that does the same thing as our while loop, except it initializes our C, which is a good thing because we don't use our C anywhere after this loop. So when we define our C up here, it's visible up top, it's visible in the loop, and it's accessible down here. And again, this is a simple program, so we're not really seeing a lot of use here, but as we get into more complicated things, complicated programs, we're going to have all these variables that are always kind of in play. And it's certainly not the best way to do things. We want to limit the scope of our variables as much as possible. So in this case, our C variable only exists during this loop. So this is all good. I can save this, and I can compile it. We're going to call it IO again, and this is the copy IO file. We got a, that's me just forgetting how to use the compiler from the command line. We have to call it an output file, IO, and then copy IO. There we go. And if we do this, we're going to see it does the exact same thing as it did before. It is certainly not Thursday today, but for whatever reason, it's just a word that I like to say a lot. We read books, specifically the C programming language, KnR C, and our program is doing everything it was doing. So I'm going to pass it end of file again, which was Control D, and there we go. So this is a good example of us limiting the scope. Let's look at that again. Limiting the scope of a variable. The C doesn't need to exist past the loop, so let's define it in the loop and limit its scope that way. This is an example where you might want your variable to live outside your loop is when you're going to use it after the loop. So I've got another example here, and what was it called? Oh, char count. There we go. This is on the very next page. On page 18, we have a character counting program. And in this case, we see a very similar thing. We see that we have a long variable that's been defined. Then we declare the variable up here on line 12. We define it to be 0, and then we start to use it in our loop here. Thing is that we want to keep it. In the end of this program, we want to print the value of whatever's in NC, so the number of characters counted. So we do want the variable to live beyond the loop, therefore it's okay to define it outside of it. Let's do our fixes here. In main, we are going to return 0. And really, I'm happy with the way this is, except for the fact that we declare the variable on one line and then we define it on the other. We say we're going to have a variable named NC, and then we give it a value. And this is something that in modern programming we try to combine into one. As soon as you declare a variable, define it as well, then it's got a pretty good, we know that it's in a good state. So this program is going to do what we want it to do. And in particular, in our last video, I talked about how we shouldn't use printf, we should use puts when we're just putting out a string. In this case, this example uses printf for its intended purpose. We pass it a format string, and then we pass it a variable. And what printf is going to do is put that format string out on our command line, and it's going to substitute this LD, which is a long digit or long decimal representation of an integer, and it's going to plug NC into that spot. So let me pass this. I'm going to write quit. Oh, I'm going to write and quit that. Now let's do this one. And this one is we're going to call count, just because why not? This was char count C. And what I'm going to do this time is I'm going to run count, but rather than me entering stuff from the command line, I'm just going to pass it in the source file. Pass it in char count, and now it's going to count all the characters in our char count source file. There's 252 characters in there. So that's an example of the program working as intended. And in that specific program, we saw that we wanted our variable to live longer than the loop, so we defined it outside, worked with it in the loop, and then used it afterwards. So we wanted the variable to have a wider scope than just the loop in this example, whereas in the copy one, all we needed to do with that C was use it in the loop, and then it doesn't exist anymore. Incidentally, I talked about defining it as soon as you could. I did not define this to anything because in the very next statement, I knew that I was going to give it a value with getChar. And we're only going to be giving it values from getChar, so defining it to anything else doesn't really make much sense. But it's good that we declare it and then define it in the very next statement. So there we go. Those are our examples there. Beyond this, I am, what am I sitting? I'm about 10 minutes here. We can experiment and explore some of these, some of our programs a little bit deeper. You don't have to just complete the exercises as given to you in the text. You can find ways to play with them. And one example I'm going to give you is we are going to include the ctype header. And the ctype header, let me just get out of here for a second. I'm experimenting with a larger terminal today, so I usually have two terminals side by each so that I can look at my man pages while I still got my programs open. But we're going to look at the ctype header in the man pages, and we're going to see that it includes a lot of fun things with character types, and in particular it gives us all of these functions here. We can test the status of a character. Is it an alphanumeric character? Is it just an alphabetical character? Is it a blank? Is it white space? Is it many things? And this header also gives us two upper and two lower. And we're going to use two upper today, which is going to take our character and pump it up to an uppercase character if it's not already. So let's check out the copy IO. There we have our C type. And now what we're going to do for C is equal to, well, C is going to get a char. We're going to put it back, but we're going to change this to a to upper version of C. So we're going to get a character from input, we're going to put it, but we're going to capitalize it. And this is just going to be our way of turning everything into a shout. So if I compile this again, gcc/out.io, copy IO, and I'm going to run IO again, and this time when I say hello, I'm going to get it shouted back to me, hello. So this is the Garrett Morris of programs for C. Our top story tonight, there you go, that's some old Saturday Night Live references for you, but let's kick out of there. And that is our example for today. So feel free to experiment with the C-type header as a way to just have a little bit more fun with your exercises rather than just, crunching through all the exercises and trying to get to the end of the chapter as fast as possible. Thanks for joining me today, and I hope to see you again next time.